Hi, and welcome to our video series about biomimicry life principles. Life principles are design lessons from nature and can be found basically in all life on Earth. And for each of the 26 principles, we're going to show you an example from the ecosystem of a tree. Just like in nature, all principles are interconnected in a complex web. But to understand them a bit better, they're organized into 6 master principles and 20 sub-principles. So how does life deal with resources? How does life on Earth distribute materials? How does life use energy? In this video, we're going to be talking about 5 principles, starting with the master principle, be resource efficient in material and energy. And 4 sub-principles, use low energy processes, use multifunctional design, recycle all materials, and fit form to function. Our examples from our ecosystem of the tree are going to be the story about wild nesting bees, story about fungi, tree sponges, and how they deal with energy, temperature, woodpeckers and their fascinating beak and what they can do with it, the recycling of materials in an ant colony, and the simple slight change to one body part in some beetles that has a big effect. Be resource efficient. And our example in nature for this principle are wood nesting wild bees and their brood strategies. So there are very many species of bees. Most people only know the honeybees, but there are far more wild species of bees, and most of these bee species actually live solitary. So one female actually has a strategy to make her own little brood cells normally, to feed her own larvae and get them through, so to make the next generation. So many wild bees, they don't live in a big colony, they live solitary. And then there are many strategies, and they're the wood nesting wild bees. So they make their brood cells in wood. And many of them very efficiently use already existing little tunnels that they find in wood, made by the larvae of beetles, for example. But what do they need to effectively guarantee their offspring's survival? They need the right food, because they make brood cells where they don't only lay the eggs in there, they give them a packet of food for when the larva hatches and feeds. So they need the right plants, the right flowers, close to their brood cells so they can collect enough nectar and pollen. They also need clay, moist clay, because they use moist clay to build intermediate walls for each brood cell and to close off the entire tunnel outside. And of course, collecting nectar and pollen, collecting clay, building this, flying around, this all takes time, takes energy. They need to be very efficient. So they need to be very efficient in finding the right spot where they want to build their brood cells, and finding a spot that also is in close proximity to food resources and clay resources. What's our design guideline here? Skillfully and conservatively take advantage of resources and opportunities. In our ecosystem of the tree. Wild nesting bees are an important part, of course. They're everywhere flying around, and in our tree, in parts of the trunk where the wood is older, maybe already dead, or in dead branches lying around close to the tree, there are many wood nesting wild bees, and they have a very important function in an ecosystem, the function of pollination. Use low energy processes. And our example for this principle are the tree sponges and their use of catalyst enzymes. So tree sponges are fungi that are able to digest and eat wood. Something that not many creatures and organisms on this planet can do. Wood is a very, very strong structure. And these tree sponges are able to process and kind of digest lignin, the parts of wood, these molecules. And they do this by using enzymes that help them to catalyst this reaction, this chemical reaction, to process the wood. And they don't need a very high energy, even though you could say you would need a lot of energy to break up this structure of wood. They use these enzymes to give them the ability to process wood at very low temperatures, at the temperatures that are just outside in a normal woodland during the year. Absolutely fascinating. Our design guideline here: minimize energy consumption by reducing requisite temperatures, pressures, and or time for reactions. In our ecosystem of the tree, the sponges are very important. They start living on trees, in trees, and especially when a tree dies, these sponges are essential to process the wood. Only most fungi species can actually process wood. Most other organisms, like I said, can't do that. So these tree sponges are very essential to actually make the energy stored in the wood accessible for other organisms again. And this is the first part in turning a dead tree into new life, new soil, other organisms. Use multifunctional design. And our example for this principle in nature are woodpeckers and their amazing beak that they can use for many different things. So woodpeckers are birds that can stay in temperate regions over the winter. So they can stay in the cold winter in Europe, for instance, and they can always find little animals that they can eat, little insects, for instance. How do they do that? They use their beak to peck on a tree. They peck on the outside of the tree, and they can find insects, larvae, eggs hiding in different layers of the tree bark. So it is the beak is an instrument for them to find food. Of course, they also use their beak to defend themselves if they're attacked, or to attack a different individual if it's coming into the territory of a woodpecker. So one woodpecker has his territory, the other one has the other territory. Sometimes they fight. So they use their beak for fighting or for defending themselves. They also, of course, use their beak as a tool to just take little things that they need, like little insects, just finding them on top of something, just taking it and eating it. They also use it for making a nest, so taking nest material and placing it in the correct order to make a nest. They also use their beak as an instrument. Woodpeckers are the drummers of nature, and they actually sing through pecking rhythmically on a tree bark. So the beak is also a musical instrument. So one simple design, the beak, is used for very, very, very many functions. Our design guideline: meet multiple needs with one elegant solution. Woodpeckers are a very important part in many ecosystems of trees because, on the one hand, they eat many little animals living on the tree bark. Maybe if there would be no woodpeckers, some would be too much for the tree. Also, they make tree hollows, which are very important sub-ecosystems in trees and also in dead wood. Tree hollows that are a new space to live, a new ecosystem for many organisms. And woodpeckers are also important for the sound that we all know in an ecosystem of a woodpecker calling and drumming. Recycle all materials. And our example in nature for this principle are anthills of the red wood ant and the circular economy that they manage to develop in a forest. So these red wood ants often build huge anthills, and they collect especially spruce needles, they collect little twigs, and often they start building an anthill on the stump of a actually old dead tree. And then they build this huge hill, and their colony, so many chambers and tunnels, are in the hill but also in the ground, in the soil, spread out. And they collect different materials and energy all throughout the woodland, because they have their chambers where they feed the larvae, so they bring food. They have their little nurseries. They have other storage chambers where they store food. They have deposits for all kinds of things. Very complex system in ant colony. So they reuse a lot of energy and materials from the forest and accumulate it at this one spot. And over many years, the accumulation of organic material here builds a perfect basis for the growth in the future of a new tree on this spot where there are many nutrients in the soil that have accumulated through this ant colony. What's our design guideline here? Keep all materials in a closed loop. Ants are an extremely important part of any ecosystem of a tree. Ants live in all parts of the ecosystem of a tree. They crawl around from top to bottom and soil and fulfill very many functions in a healthy ecosystem. Just one simple example of many. Of course, ants are very important food for woodpeckers, for instance, that we just talked about. Fit form to function. Our example from nature for this principle are rose chafers and their wing form. So chafers are a kind of beetle, and beetles have wings. And like many insects, they originally have, or they still have, 4 wings, so 2 pairs of wings. But the special thing about beetles is that in most beetles, the first pair of wings has developed to a kind of protective armor, and they're not used for flying anymore. And most beetles, when they want to fly, they need to open up their protective armor, and the second pair of wings underneath can now be used for flying. Very effective. One downside is the protective armor if it's opened up, is aerodynamically not very effective and actually has a braking effect in flying. So rose chafers over time have developed a very simple adaptation in form to make it easier to fly effectively. Just a slight tiny edge on the side of the protective armor has given rose chafers the ability to fly with their second pair of wings without having to open up the protective armor pair of wings. So even though they're quite big, up to 2 centimeters, they are extremely effective, agile flyers, which is very important for them as day active visitors of different kinds of flowers. Our design guideline here: select for shape or pattern based on need. So chafers are very important, like many beetles. They're one of the big 4 orders in the insect world, the beetles, and chafers fly around day to day, eating nectar, eating pollen, and fulfill important functions. On the one hand, also some kind of pollination for some plants, and of course they are very important food for other animals, for predators, for instance, and fulfill many other functions that most of us probably don't know. So that was part 5. If you want to get the whole story, check out the other 5 videos about the life principles, or our video about what is biomimicry. Thanks. See you next time.